So now we're going to look at number 7 on the review. A car traveling at 95 kilometers per hour strikes a tree. The front end of the car compresses, and the driver comes to a rest after traveling 0.8 meters. What was the magnitude of the average acceleration of the driver during the collision? Express the answers in multiples of g, where g equals 9.81 meters per second squared. So the point of this, if you've ever heard g-force, this is what they're talking about, multiples of this acceleration. So we'll cover that once we get the answer. So we're traveling at 95 kilometers per hour. That is our initial velocity. So 95 km. It's supposed to be an R. There we go. All right. We want this, if we look, we need meters per second squared. We're in meters here. So if we do our conversion, hopefully everybody can do that by now, we get 26.4 meters per second. We know it travels 0.8 during the motion, so our delta x is 0.8 meters. And we know it comes to a rest, so since we say it comes to a rest, we know our final velocity is 0 meters per second. We want to know the acceleration. So what don't we have information for? Time. So we need to look at the equation that's not reliant on time, and that's number 4. So that's the VF squared equals V naught squared. Turn this on. V naught squared plus 2a delta x. Alright, so we want to solve acceleration here. So if we do that, we get a equals VF squared minus V naught squared divided by 2 delta x. So now all we'd have to do is plug in. So our final velocity is 0, so minus 26.4 meters per second all squared divided by 2 delta x, 0.8 meters. Okay, we throw that in, we get a negative 435.6 meters per second squared. Alright, so now we get multiples of g. So all we have to do is divide this number by our value for g. If we set that up as a conversion, if that makes more sense, we say 435.6 meters per second squared. And I dropped that negative because the question asked about magnitude, so we don't need to know the direction. So we can say 1g is 9.81 meters per second squared. And if we do that, we get 44.4 G's. So what that means is 44.4 times the force of gravity. So if you see that, if you see g-force anywhere, it's just how many times g goes into that number. All right.